Now let's look at this counting problem in geometry. Let's count the number of triangles. So we can count according to the size of the triangle again. And as long as you count in an organized way, you should be able to find the answer. And if you want, you can pause the video and count it. Alright. So if you count it, you will get the answer is 15. No, the answer is, yeah, it's 15. 15 triangles. But I always do the counting in a slightly different way. So look at the triangles. Each triangle, like this small triangle, you can write it as triangle O, B, C in this case, right? Each triangle has a vertex O, like O, D, F, like these type of triangles. The O is always there. So if we disregard O, forget about this O, then the triangle is determined by the segment BC and DF, like this. So basically, each triangle corresponding to each line segment, like line segment BC, line segment DF. And this is quite similar to what we discussed in counting the number of squares, that each square somehow is corresponding to its lower left corner. So instead of counting the triangles, we may as well count the number of line segments. And we had a video on how to count the number of line segments. The best way to count the number of line segments is to associate with a pair of letters, because BC is a pair of letter, DF is a pair of letter. And then in this case, you can associate 6 letters for the first letter. I mean, you cannot use O here. You have to use A, B, C, D, E, F. And then you have for the second letter in the pair, you have 5 choices. And then you because you have double counting, BC is the same as CB, you divide by 2 and you get 15. So this is another method in counting this particular problem, and this method is used quite a lot in counting, is that you translate a problem into a different problem which may be simpler. In this case, we translate the problem of counting triangles into the problem of counting line segments. Okay, so let's go to our next example. Let me save. And go to next example. Ah. So we count rectangles, and this includes stuff like this, right? And you can imagine there are quite a few rectangles in the picture. So now it will be very difficult to count it by size, because you could have size, in this case, size 6, and you could have size, I don't know, 3 by 4, size 12, size 3 by 5. There are various different sizes. So if you do counting by size, this looks very tough. Okay, so what is the idea? And in this case, there's a little trick that one can use. Namely, the trick is similar to what we did for counting triangles. Instead of counting the number of rectangles, we count something else. We recognize the following fact, is that for any rectangle, like this rectangle, it has two sides, basically. I mean, these two, of course, are parallel, the top and bottom parallel, the left and right are parallel. So it has a left side and it has a bottom side. Okay, and if we project down here, the bottom side gave us a line segment here. And the left side gave us a line segment here. And the point is, each rectangle is basically correspond to a pair of line segments. So whenever you have a line segment on the left and line segment to the bottom, you get a rectangle. So let's look at the example. So for example, I pick a line segment here, this line segment, okay? And I pick a line segment here, this line segment. So it corresponds to a rectangle, where the rectangle is on top of these line segments and to the right of this line segment. So it will be here, 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 and here, you see? Any pair of line segments give you exactly one rectangle. So now the question is become counting how many pairs of line segments. Okay, so how many pairs of line segments? Well, how many line segments are there in the bottom? And to the left. And this we know how to do. Counting line segments is just counting how many. Basically choose 2 points out of how many points here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So basically choose 11, choose 2 points out of 11. So the first choice you have for the points 11 points. The second choice 10, and then you divide by 2. So this is 110 divided by 2 is 55. And the number of line segments to the left, and this will be the same actually, 11 times 10 divided by 2, because it's a square here, so I need to go 55. So how many rectangles are there? It will be 55 times 55, and that will be 30, 25. Alright, and actually for this multiplication, there's a trick to do it. It's a little trick. Squares of 55 is the last two digits are 25, and the first two digits is 5 times 6, 30. That's how I get it quickly. 30, 25. And this should remind you of the problem we did as warm-up problem. Remember warm-up problem, we are like, it's 2 by 2 squares. And we have 3 points here, and you choose 2 points, it will be 3 times 2 divided by 2. That's how many line segments in the bottom, 3, and line segments to the left is also 3, and 3 times 3. That's how we count it. We count for the warm-up, and we counted 9 rectangles, right? Okay, so this is how you count the amount of rectangles, and this trick works basically in all the cases.